G'day and welcome to this second video in which I demonstrate the application of the product rule in calculus to three functions. Here's the first one. This set of videos, by the way, is thanks to one of my subscribers called Chelsea. So thank you, Chelsea, for asking about these and providing me with the examples. Now, to find the derivative of this, I first noticed something interesting, quite apart from the fact that we have two expressions multiplied. The second one is a power of a function, so we're going to use the chain rule embedded inside the product rule. But I want you to notice there's something a little bit bothersome about this, because normally we like the x squared first, and we certainly don't like negative signs in front of it. So I'm going to show you a mathematician's trick, if you like. And you should use it every time you see, or almost every time you see, an expression like this. And this is the trick. If you have 1 minus x squared, if you remove negative 1, or a minus sign if you like, from the expression, and reverse it, x squared minus 1, they're equivalent statements. You can see that minus x squared is minus x squared, and minus negative 1 is plus 1. They're the same thing. So if I raise these to the power 4, this side, then I've got to raise this side to the power 4, which means I raise the negative sign to the power 4, and I raise this to the power 4. What is a minus sign raised to the power 4? Or minus 1 multiplied by itself 4 times. Minus, 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 minus. There are 4 negative signs. And those make a positive. So if I remove that, you can see that they're equivalent statements. In fact, they're identical. We could use an identity, which means they're true for every value of x. So rather than this, I'm going to write that. So that's going to be my first improvement. Now, you can go ahead and find the derivative, still leaving it in this form. It's just a bit more clumsy, and you've got some tidy up at the end, and at the end you're probably going to have to reverse it anyway. So just learn this trick, and now we're going to find the derivative of this. Well, since we have two expressions here multiplied together, we're going to get two parts to our product rule. We're going to find the derivative of the first thing we encounter and leave the second bit alone. And then we're going to leave this first bit alone and multiply by the derivative of this. And that's where our chain rule is going to appear. Now, that's given the structure for the product rule. We don't have to remember it. We don't anymore, beyond this. And it frees us up to concentrate on the derivatives of each bit. Well, the derivative of this first bit is very elementary, isn't it? It's 1. It's one of the easiest ones you're likely to do in your school textbook. But moving down the other end, the derivative of this, now that we've left this alone, the derivative of this second bit, we have to do the chain rule. Now we deal with this power first, because this is the function that we apply to this function. How do we find the derivative? Well, it's going to be 4 times x squared minus 1 cubed, and that deals with the power. And then we multiply by the derivative of what's inside, which is 2x. Now, if you're not familiar with doing the chain rule like that, without using substitution, then I encourage you to watch my video about doing the chain rule in 20 seconds. It's a longer video because of the examples I use, but I think you'll find it beneficial. It's my most popular video so far, and I encourage you to watch it. Well, let's see what we've got. We have this expression and this one, and we look first of all for common factors. Now obviously 1 is a bit redundant. We can cover that up or remove it. We certainly won't write it on the next line. So the only possible common factors are these ones. And the rule is, again, we remove the lowest power. The lowest power is 3. 3 is less than 4. So we can take out x squared minus 1 cubed as the common factor. Let's see what's left. Now if I remove x squared minus 1 cubed from that, in other words if I divide this into that, I subtract the indices, 4 minus 3 is 1, so I've got one lot of it. So that times that, with a 1 here if you like, will give me x squared minus 1 to the power 4. I covered up the 1 because 1 times anything really doesn't make a difference, and it was, in a way, it was just getting in the road. Plus, now if we take this out, and you can see this is the entire factor here, isn't it? X squared minus 1 cubed. Then we're going to be left with all of this. Now 4 times 2x is 8x times this. So I'm going to write it 8x times x plus 2. And let's see what we get. X squared minus 1 cubed. Expand this. X squared minus 1. And here we're going to get 8x squared. And 8x times 2 is 16x. Now, as I showed in the last video, because this is more complicated, because it's a higher power, if you like, than this, we're going to put it second. It's just a convention of writing. So let's simplify this and put this expression first. Well, we've got these x squared terms. So 8 of them here and 1 of them there is 9x squared plus 16x minus 1 times x squared minus 1 cubed. Now all that remains is to check this over to see in fact whether this could be factorised. Well, a negative 1, we're only going to get negative 1 times positive 1, and at the front we have 9 times 1 or 3 times 3, and no combination of that's going to give 16. So this is not factorisable using integers. So there we go, that's the complete answer. And I hope you enjoy it. Now we're going to move to the next one, which is a bit more interesting. This one involves a product of two expressions, both of which require the chain rule. So let's have a look at that. So here we go. We can see we have two expressions again. At least this one has this around the right way with the x squared first. And they've both got a power of 2. So we're going to use the chain rule in both, but first let's deal with the product. When we find the derivative of a function times a function, we find the derivative of that and then multiply it by this expression. And we leave this one alone and multiply by the derivative of that. Now all I've done is I've left room for those two derivatives. So the derivative of the first one goes here, leave that alone. Then we leave the first one alone and put the derivative of the second one there. And I like structuring it like this because I can keep control and good order. Now, what's the derivative of this? It's a chain. It's a function of a function. So we deal with the outside function first. What's the derivative of something squared? Well, it's 2 times whatever that was to the power 1. I will write it in. Times the derivative of what's inside. What's the derivative of x squared minus 1? It's 2x. Now, moving to this one, this is a chain as well. We deal with this power first. The derivative of something squared is 2 times that to the power 1 times the derivative of what's inside, and the derivative of x plus 5 is 1. Now, we look along here for common factors. Well, first of all, I can see this 2 is common, or at least a 2. This has got two 2's we can choose from, but this is 2 common. We have this in common, and again we would take the lower power, so it's this one we would choose. And we don't have any x's, but we do have an x plus 5. And this is the lower power. This is lower than the 2, so that's going to be common. So let's take them out. We're going to take out 2. We're going to take out x squared minus 1. And we're going to take out x plus 5. The rest is going to be left alone. Let's take it out. 2 out of this gets rid of that. That to the power 1 has got rid of that. We're left with the 2x. And dividing that into that, because that's squared and this is only the power 1, we subtract the indices and we're going to have another x plus 5 here. So this times this gives us all of that. 2x, x squared minus 1, and x plus 5 times x plus 5 is x plus 5 squared. Let's move to this next bit. Plus, must write that in. What have we taken out? We've taken the 2 out. We've taken the x plus 5 out completely. The x minus 1, we only took out 1, the power of 1, but there are 2 of them here, so we leave one of them. And all that's left is this times 1, and we wouldn't bother writing times 1. Multiply by 1. It's a multiplicative identity, so it leaves everything untouched, or just exactly the same as before. So what have we got? We've got 2, x squared minus 1, x plus 5. Now let's tidy this up and see what we get. We get 2x squared plus 10x plus x squared minus 1 equals. Now here we start to try and put them in order. Which of these is going to be the next simplest expression apart from 2? Well, it's not a quadratic. This is going to be a quadratic as well. That's the simple one. So let's put it next. So this is part of the convention of just putting simple things at the front. Now, is this or this likely to be more complicated? I think this is going to be simpler than that. That looks like it's going to have extra bits. So I'm going to put the x squared minus 1 next. And here I'm going to combine this. So putting the x squareds together, I'm going to get 3x squared plus 10x minus 1. And 3's a prime, 1's a prime, and if I combine a 3 or a 1 times a 1 and a 1, I'm not going to get any combination that will give me 10. So that can't be factorised using integers. I could factorise that if I wanted into x plus 1 times x minus 1, but I think that's a pretty fair way of leaving that answer. So there it is. Chain rule in both cases, but if we write the product rule out first, or at least the structure first, that allows us to deal with the chain rule in an uncomplicated way in situ. Okay, let's keep going. We've got one more to go in this video. We'll try and cover it very quickly. It's fairly similar to this. Now this one is so similar to the previous one that we're going to speed up. We have a product of two expressions. They've both got powers, so we're looking at the chain rule inside the product. Let's deal with the product first. We're going to have two bits. Derivative of this times this, unchanged. And then we leave the first one unchanged times the derivative of the second bit. So I've left room for the derivative here and the derivative there. Derivative of that, leave that alone, and then leave this alone and derivative of that. Chain rule, what's the derivative of this? Well, the 2 comes down, x squared plus 1, that deals with the power. Then we multiply by the derivative of what's inside, which is 2x. What's the derivative of this? 2 comes down, x plus 1 to the power 1 if you like, times the derivative of what's inside. Let's look for common factors between this and this, since we have these two terms. Well, 2 is common. Let's write that down. X plus 1, or let's do the x squared plus 1. x squared plus 1 is common. The lowest power is 1, so we'll take that out. There's an x here, but there's no x over here. There's an x plus 1, and the lowest power here is 1. So we'll take x plus 1 out. And let's see what's left. That comes out, they're the same. So the 2x remains, and this divided by this, subtract the indices, we get x plus 1. You can quickly check that times 2x, and x plus 1 times x plus 1 is x plus 1 squared. Plus, and now we take these same things out of here. We take the 2 out, x plus 1, now this is x plus 1, but this is x plus 1 squared. So when we divide this out of this, we're still left with an x squared plus 1. And the x plus 1 comes out, and of course times 1 we won't bother with. Let's leave this alone. And now we expand this to see what we get. 2x times x is 2x squared. 2x times 1 is 2x. X squared plus 1. And now we'll try and put it in a good order. 2 is simplest. That will be our next simplest term. This is going to be simpler than that. And unlike the previous example, this is not factorisable, because the other one was x squared minus 1, this is x squared plus 1, not factorisable, not in the real number system anyway. And in this one, we get 2x squared, and x squared is 3x squared, plus 2x plus 1, not factorisable. So there's our solution to that or finding the derivative of that function. Well, that's the second bracket of 3. I hope you've enjoyed it. If you have, then please leave a comment, like the video, subscribe, and as you're doing all of that, you can thank Chelsea for asking me to prepare these videos. Thank you for watching.